When you're doing an example like this one, you're given two triangles as similar in the instructions. With this information, if you know two triangles are similar, you can usually figure out a scale factor. The order the letters are written in does matter. J and P are comparable, K and Q, and L and R. They are the corresponding letters. Now, if I know JK is 12, there's JK, and I know PQ is 15, there's PQ. The scale factor between these two figures will exist between these two numbers right here. Your scale factor is known as A over B. For this example, I'll use 12 and 15 to determine my scale factor. I won't leave them as 12 and 15, but instead I will reduce them as you should always do with a fraction. Each of these numbers reduces by 3, so I will be left with a scale factor of 4/5. The scale factor of 4/5 is perfectly fine as is if we're doing work with the perimeters of our similar figures. However, we're trying to work with the area of the similar figures for this example. Since we're trying to determine the area of one of the figures based on the area of the other figure, we're going to take our scale factor of A over B and we're going to square it and get an A squared over B squared. For this example, A squared over B squared, 4 squared over 5 squared, gives us 16 over 25. This is the ratio we're going to use to find the area of the second figure. 16 is to 25 as 30, the area of the first figure, is to x, the unknown area. The product of the extremes is equal to the product of the means. That means 16x equals 25 times 30. I need to solve for x. I'll divide each side by 16. If I reduce by 2 in my numerator and denominator, (25 times 15), 25 times 5 is 125, times 3 is 375 over 8. If your fraction didn't reduce here, as long as you simplified everything you could, you don't need to worry about reducing this. It's already completely reduced. So my area of 375 over 8 inches squared is the answer to this problem. Nowhere did I stop and find the missing legs of the triangle. You should not be doing that. All you need to do is find your scale factor. If it's area, use that to adjust your proportion accordingly, and then use that proportion to adjust your ratio accordingly, and then you're going to use that ratio to create a proportion that we'll use to solve and find the missing information. The area of parallelogram ABCD is 54 square meters. The area of parallelogram FGHI is 150 square meters. If parallelogram ABCD is similar to parallelogram FGHI, find the scale factor of FGHI to ABCD. Then find the value of x. When we find a scale factor of one figure to another, it's what you need to multiply by to get from this figure's dimensions to this figure's dimensions. In a nutshell, that means you have to take the side length from this figure and put it over the side length from this figure. You won't use this figure's dimensions first. So if I'm trying to go from this figure to this figure, the way I'll set up my scale factor is using information from this figure over information from this figure. The one you're going to is in your numerator. The one you're coming from is in your denominator. So you're going to take information from the second figure, the one you're going to, put that in your numerator, and then you're going to use the information from the figure that we're going from and put that in the denominator. I already have both areas. That means I'm going to use my areas to come up with the scale factor. If I had side lengths, I would use side lengths to come up with the scale factor. The scale factor will be A over B. Since I have areas, that means I already have A squared over B squared. We're going to this figure. The area of this figure is 54 meters squared. The area of this, 150 meters squared. We take the figure we're going to and put that in the numerator, and the one we're coming from, and put that in the denominator. Now, if I want A over B, but I have A squared over B squared, what do I need to do to get this into the right condition? I'm going to need to take the square root. But to make our lives easier, what you should always do is reduce first. So I'm going to go over here. Now, while I know a few larger numbers that divide into both of these, I'm going to start with 2 since they're both even. Half of 54 is 27. Half of 150 is 75. These numbers can reduce again by 3. 1/3 of 27 is 9. 1/3 of 75 is 25. Keep in mind, we did not take a square root, all we did was reduce. So, just to restate, A squared over B squared is equal to 9 over 25. We're not reducing the fraction. What we're going to do is take the square root of each side. When we do that, we get A over B equals, what's the square root of 9? 3. And what's the square root of 25? 5. So the ratio from A to B is 3 over 5. That means our scale factor is 3/5. We'll use our scale factor to find the missing side length. The last thing we need to do is find the value of x. 3 is to 5 as x is to 10. The product of the extremes equals the product of the means. 3 times 10 equals 5 times x. Notice I'm not writing an equal sign here. This does not equal that. So I'm drawing an arrow to say it sort of causes or yields that. Then we'll divide both sides by 5. That means x is equal to 3 times 2. X equals 6 meters.